Hello, calculus fans. Let's suppose that we measure the temperature on a metal plate with this function. T of xy is equal to 4x squared minus 4xy plus y squared. So depending on where you're at, the x and y coordinates will tell you the temperature through this function. We have an ant that's walking along the metal plate, and it goes along a circle of radius 5 centered at the origin. And we'd like to know what's the highest and lowest temperature that the ant experiences. So that means our goal is to optimize f of xy equals 4x squared minus 4xy plus y squared, subject to this constraint that g of xy is equal to x squared plus y squared equals 25. You'll notice that we're using the word optimize here, indicating that we're going to do both maximum and minimum values. As usual, with our Lagrange multipliers, we'll set del f equal to lambda del g. Del f is equal to 8x minus 4y and minus 4x plus 2y. And then del g is equal to 2x, 2y. So, if we create our Lagrange multiplier equations, we get 8x minus 4y equals lambda times 2x, and minus 4x plus 2y equals lambda times 2y. And again, we're interested in solving for x and y with these equations together with our constraint equation. Notice that if we multiply both sides of the second equation by 2, we get this. And now you see that the left-hand sides are the same, except they're off by a minus sign. So if we add, we'll get 0 equals lambda 2x plus lambda 4y, and factoring, we'll get 2 lambda times x plus 2y is equal to 0. That means either lambda is equal to 0 or x plus 2y is equal to 0. So we're going to treat these two possibilities in two cases. So in the first case, we've got lambda equals 0. Then, if we take the equation 8x minus 4y equals lambda 2x, that tells us that 8x minus 4y equals 0, or if we simplify this, we'll get y equals 2x. Now we're going to use our constraint equation. Remember, that was x squared plus y squared equals 25. So we plug y equals 2x into that, and if we simplify all this, we'll get x squared equals 5. You should double check the algebra. So that means x equals plus or minus square root of 5, and since y is equal to 2x, we'll get y equals plus or minus 2 square root of 5. So we now have critical points, square root of 5, 2 square root of 5, and negative square root of 5, negative 2 square root of 5. All right, file those away. We're going to use those later. We have to move on to case 2 now. Case 2 is when x plus 2y is equal to 0. So now we have x is equal to negative 2y, and if we plug that into the constraint, we'll get negative 2y quantity squared plus y squared equals 25. Simplify all that, and we get y squared equals 5. So now, y equals plus or minus square root of 5, and now look at this funny symbol here. Since x is equal to negative 2 square root of 5, we're going to say that x is equal to minus plus 2 square root of 5. This is actually a standard notation in mathematics. What it means is that when y is equal to positive square root of 5, x is equal to negative 2 square root of 5. When y is equal to negative square root of 5, x is equal to positive 2 square root of 5. So these two notations here, the plus or minus and minus plus, are indicating that y and x have to have opposite signs. So we get two new critical points, 2 square root of 5, negative square root of 5, and negative 2 square root of 5 square root of 5. So we now have two more critical points. We're going to plug these 4 critical points back into our temperature function to see which is the highest and which is the lowest. All right, I'll spare you all the algebraic details. The first 2 that you plug in, you'll get a temperature of 0, and the second 2 that you get, you'll get a temperature of 125. So the method of Lagrange multipliers tells us that the highest temperature experienced by the ant is 125 degrees and the lowest is 0 degrees. Okay, that's all for now.